try to construct the decoder for the input sigma of 0 comma 2, 0 comma 2, right? How many decoders are required of size 2 by 4? Only one decoder of size 2 by 4, right? If I am going to have two input lines, one is I1, another one is I0, you are going to have four output lines, O0, O1, O2 and O3. Okay, fine. Now, where might be your output need to be high? One is at 0 level, another one is at 2 level. You are going to define like this. So, here you are going to get the Boolean function f of x comma y, right? The same circuit diagram I can able to redraw in another way. Instead of using OR gate, I can able to redraw in another way. Like, try to observe. I am going to use only 2 by 4 decoder. Input is I1 and I0 and outputs are like this. Okay, fine. Now, instead of using OR gate, I am going to place one vertical copper wire. Okay, assume that these horizontal are also copper wires, right? Now, to get the output 1, for 0 comma 2, meaning that if I am going to get this line activated, or to get this line activated, I am going to pass the values from here. But for these two cases, only I need to get the function f of x comma y, means I need to get here high voltage. So what you can do? Can I make connection here? If I make connection, what will happen? Assume that four horizontal lines are there. If 4 horizontal lines, I have connected with some lines, right? If I am going to connect it, for example, with example I can say, right? If I am going to say it has 0, 1 as input, high output will be generated which line? Second line, meaning that my current is passed through here. If current is passed through here, if vertical is connected to that line, is it connected? No. As it is not connected, what might be the output you are going to get? Low. Am I right or not? Fine. So, for example, if I am going to give the input as 1, 0, which line is going to be activated? Second line is going to be activated, right? Meaning that voltage will be passed here. As voltage is passing here, this line is connected with another line, that is vertical line. So it can able to pass the same high voltage to this particular line also. So it is going to produce high output. So this is the way also I can able to write. Meaning that if I want to define one function, basically in decoders you require one OR gate. Similarly for this kind of representation also, in order to represent one function, how many vertical lines are required? You require one vertical line. Okay, fine. Suppose for example, I want to construct three functions like 1 comma 2 and minterms of 2 and minterms of 0 comma 1, right? So can I able to implement with the help of a single 2 by 4 decoder? Yes or no? So basically what you will do, you can take simple 2 by 4 decoder and it is going to have two lines as input. One is I1, another one is I0, and it is going to produce 4 lines as output, right? You can draw the circuit diagram for this, right? So meaning that I am going to take simply 1 comma 2 and I am going to make it with OR gate, right? So instead of that, what I can do, can I take one vertical line and I can take another vertical line which is meant for another function, I can take with another vertical line which is meant for the another function. For example, let me call this as a function f, g and h, right? So for the function f I have made one vertical line, for the function g I made one vertical line, for the function h I made one vertical line. Now where we need to make link both horizontal line as well as vertical line. For function 1 I need to make it connection at the line number 1 and at the line number 2. Similarly, for the function g, I am going to make it connect at the line number 2. Link at the line number 2. Similarly, for the function h, I am going to connect at the line number 0 and at the line number 1. Right? For example, I would like to get the output 1 for the function g. Right? So for the function g, what is they are expecting for 2, right? 2 means what? 1 0. 1 0 means power is going to pass it to the third line here, right? At where they are connected at this particular point as well as this particular point, right? So when it is connected at these two particular point, what about the g function? Is the g function is going to get the output or not? Yes. So g function is going to get output. So I can say that I can able to implement all the things. Okay, fine. So meaning that simply if I are able to observe, I am going to have a data like 0 1 0 1, 1 0 1 0, 1 0 1 1 and something like 0 0 1 1. Right? The same thing I am going to write in the form of some kind of matrix format. I have 4 vertical lines, right? So here, so assume that this is a function f, g, h, i. Let us assume, right? So if I would like to represent this data, how can I represent this particular representation? Can I represent here 1? Wherever link is connected, power is going to be transferred. Wherever 1 is there, power is going to be transferred. Similarly, for 1 0 1 0, here the link should be existed. Here the link should be existed. Similarly, for 1 0 1 1, link should be existed, link, and there will be a kind of a link. Similarly, for 0 0 1 1, the link should be like this. Am I right? So it's a kind of a simple matrix representation, right? So when you are going to give the power to this one, if I am going to connect it to a 2/4 encoder, 2/4 decoder, your power may get at respect to lines, right? Meaning that I am going to have 2 input lines. One is I1, another one is I0. Right? Now try to observe. I am passing simply an input as 1 0. When I am going to give input as 1 0, your current is going to be passed at this particular line. Power is going to pass at this particular line. If power is going to pass at this particular line, where you are going to get high voltage? You are going to get the high voltage here. I can call it as 1. And at the second line, are you going to get any voltage? No. And at the third line, yes. At the fourth line, yes. Which means that 1 0 1 is equivalent to this one or not? Means here the another advantage of decoder is, which is meant for user to represent as ROM. Means that if you would like to store certain data, we can store, and whenever we request it, by passing certain kind of data, like for example here if I observe, I passed as 10 as input, I got the respect to 1011 as output. This is what storage mechanism. So where we are going to store something, I can call it as ROM mechanism, read only memory, right? For example, I am simply passing, I need to get the data as 0011. Then what data I can able to pass here? I can able to pass simply 11. If I am going to simply pass 11, the power is going to transfer at this particular line, and already these are connected. If it is connected, it is going to get the high output. It is going to connect the high output, and these two are not connected, so you are going to get 0011. Right? So simply I can say that the decoder I can able to use it for the ROM matrix. Okay, fine. So but the question here is, how many connections are required and how many links are required in order to implement this particular requirement. Connections and links. So links means what? The interconnection between a row and a column. The interconnection between a row and a column, I can call it as simply a link, right? So if I say this is one link, right? So how many links are required now for this particular requirement? How many links are there? 16 links are there. You can able to directly understood. 2, 3, 4, 5, 6, 7. So like this, it is a kind of a 4 by 4 matrix. So we are going to get total 16 connections. So total 16 links. And how many connections are there? Connections means number of inputs and number of outputs. Number of inputs and number of output, right? So what are the inputs are there? The inputs are like 4 lines are the input. 4 lines are the inputs and total outputs are 4. So total you are going to get 8 connections. You are going to get 8 connections. Okay, fine. So for example, if I am going to have a 2 by 4 decoder, and I am going to have 4 lines as output, and there will be 3 functions. There will be 3 functions. So now, can you tell me how many connections are required, maximum connections are required at this particular requirement, and how many links are required? Links means what? Each and every interconnection, right? So you may observe at the horizontal line you have 3 interconnections, at the vertical line you have 4 interconnections. Can I say that it is 12 links? What about the connections? 4 as inputs and 3 lines as output. So can I say that 7 connections are there? Yes, right. Similarly, if I am going to generalize it, if I would like to generalize it, how can we generalize this one? Right? If it is a kind of 2, like let me take, instead of taking 2 by 4 decoder, I would like to take it as n by 2 power n decoder. N by 2 power n decoder, and assume that m functions are there. Assume that m functions are there. Then how many connections are required? M plus 2 power n. Very good. How many links are required? M into 2 power n links are required. So I hope you understood with these examples, right? Okay, now fine. So here, so the point here is number of output lines are 2 power n. Output lines are 2 power n, and number of functions are number of vertical lines. So that's why number of vertical lines are m, and number of output lines are 2 power n. So m plus 2 power n is the number of connections. Similarly, number of links means what? So each and every interconnection, which means m into 2 power n. 2 power n. Okay, fine. There is another advantage of decoder is there, that is address decoding. Address decoding, which means that we can able to, so with the help of this decoder, I can able to decode the addresses of various kind of devices. Like for example, if I am saying that a particular device address is ranging from 0 to 9, the particular device ranging from 0 to 9, then I can able to make it root for this one. So then I can say that it is called as address decoding, meaning that it simply selects various kind of devices based on the addresses. Simple, if you want to say in simple words. Okay, for example, let me write a question. If A3, A2, A1, A0 are addresses, you can note down are addresses, then what range does D1 and D2 decoder represents? Okay, and they have given a circuit here. The circuit will be look like this. It's a kind of 2 by 4 decoder where you are going to have 2 inputs, and basically you may have enable line, right? So this enable line is always going to be 1 to get the respective output, and they have defined two more devices. One is D1, another one is D2 of same size, 2/4 decoder, and another D2 is also 2/4 decoder, right? So they connected like this. These two are enable lines. And if I say that it's 2/4 decoder, how many output lines are going to be there? 4 output lines are going to be there, right? I mentioned 4 output lines. Now if I am saying that at D1 you are going to have, I don't know exactly how many output lines are there, but they mentioned it as 2/4 decoder, right? So the question they have asked is, what range does D1 and D2 decoders represents? What is the meaning of it? Right? What is the output that is produced by D1 and D2? Can you observe? So guys, try to make understood. Can I take this as A3 and A2, and this is A1 and A0. This is also A1 and A0. Right? Fine. Now, in order to get the output of the D1, what you have to do? What might be the values of A3 and A2? Can I take it as 0 and 1? If I take 0 and 1, the respective D1 circuit is going to be enabled. Means A3, A2 are going to be 0, 1. What about A1 and A0? Right, if this circuit is going to be enabled, what might be the outputs? 0, 0, 0, 1, 1, 0, 1, 1. So it is going to ranging from 0, 1, 0, 0 to 0, 1, 1, 1. So this is the particular range. So total 4 values you are going to get. Right. Similarly, to get the output of the D2, what values you have to pass here? 1, 1. If I pass 1, 1, for D2, A3 and A2 are 1, 1, and what range of A1 and 0? It should be 1, 1 and 1, 1. So here also it is going to have 4, which means that the range of the addresses are from 4 to 7, and here is from 12 to 50. So this is the respective answer for the given question. So this is the way you can able to use address decoding mechanism also, right? So if I conclude, right, so we have seen various kind of advantages of decoder. What are those? First one is you can go with any kind of basic logic circuits. What is another one? We can able to make simply converse from one kind of input data to another kind of input data. See, it means that it's not only about for all cases. So you have to go with only for few cases. Like if I am going to take simply BCD to decimal or binary to octal, like that you have to take. And parity checker is one of the advantage. And another one is it can act as a ROM matrix, and another one is address